Welcome, everyone. Thank you for joining us today at our webinar, and I hope that all of you have had a hearty lunch and grabbed your afternoon coffee. Otherwise, make yourself a good warm cup of tea or hot chocolate and get ready to spend the next hour together with us. So before the webinar starts, allow me to do a quick introduction. I am Bernadette, Marketing Specialist at DKSH Singapore, and I will be your moderator for today. Together with me is our speaker, Nicole, who is the co-founder of NAPTEC. So Nicole has a degree in business management studies and also more than 15 years of experience in the field of water purification, holding different positions as project manager, quality manager, and sales manager. And Nicole is based in Germany, so it's currently 8 a.m. over at his site right now. Am I right, Nicole? So yeah,
Yes.
thank you so much for your time today. And I would like to go over a few items just so you know how to participate in today's event. So firstly, we have already gotten our live poll up and it will continue to run until the end of our session today. So do take a few moments to answer these questions so we get a sense of the live community with us today. And if you do not see the poll section, simply find the three dots at the bottom right-hand corner of your screen. So if you click the three dots and select poll, a right panel will pop up on the screen. So we want to take every opportunity to connect with all of you. So if you could take some time to complete the poll, we would greatly appreciate it. Also, you have the opportunity to submit text questions to us by typing your questions into the Q&A panel. And again, you will find the Q&A panel at the interactive feature at the bottom right of your screen. So you may send in your questions at any time during the presentation, and we will collect these questions and address them during the Q&A session at the end of today's presentation. And yes, audience, you will be receiving a copy of our slides and the recording of this webinar via email within 2 to 3 days after today's session. So if you still have further inquiries, feel free to contact me after today's session. And moving on to the agenda for today, Nicole will be sharing with us the importance of laboratory-grade water in trace elemental analysis, where he covers water requirements, impact of water quality, etc. So after Nicole's presentation, we will leave about 5 to 10 minutes for a very exciting Kahoot quiz based on the content that Nicole covers today. So do join us at the end as you would stand a chance to win a set of Apple AirPods. So definitely look forward to it. And after the quiz, we will then conclude our session with the Q&A. So now, without further ado, I will just turn the time over to Nicole. Nicole will just make you the presenter, and then you may take over from there. All right.
Thank you very much, Bernadette.
Nicole, you're now the presenter. Yeah.
Perfect. Yeah, thank you very much for your introduction, and hi to everyone. Thanks for joining us to the webinar today. My name is Nico. I'm, as Bernadette already said, I'm the co-founder and CEO of NAPTEC. We are a German manufacturer of lab water systems, and we are talking today about the importance of laboratory-grade water in the trace elemental analysis. And let's have a look at the agenda for today. We start with a short introduction, talking a little bit about the analytical techniques, look at the water requirements, of course, on the impact of the water quality, then look at the water quality parameters which are necessary, and last but not least, the most important, like how to produce and store the required ultra-pure water. The recent enhancement in the modern analytical instrumentation have dramatically actually improved the sensitivity of the analysis. So the trace elements are now measured at the PPT and the sub-PPT levels. These levels can be achieved if you carefully control the analytical protocol. And of course, due to this low this is high sensitivity, a contamination can result from anything that comes in contact with a sample. For example, the laboratory equipment, the air, and anything is used during the sample preparation. And the limits of detection down to PPT levels can be achieved if you especially taken care with the experimental environment, as well as with the quality of the reagents and of course of the ultrapure water. Part of this webinar now looks at the most sensitive multi-elemental analytical tools. And some of the most common causes of interference will be reviewed, as well as ways of reducing this interference by specific instrument developments, and particular care taken during different analyses. The sub-PPT values for limits of quantification are achievable when the ultrapure water is produced by a system for which all parts have been carefully selected and whose configuration has been specifically developed for ultratrace purposes. This is actually also one of the main things we are looking here at this webinar. This is one of the last parts of production and the storage of the ultrapure water. But first, let's have a look at the different analytical techniques. The FFAS, sorry, the FFAS and the graphite furnace atomic absorption spectrometry are techniques that have until recently been the first choice of the analytical chemists for the trace element analysis. FFAS, this is a technology which is based on the principle that ground state metals absorb light as a specific wavelength. So metal ions in a solution are converted to atomic state by the means of a flame. And when light of the correct wavelength is supplied, the amount of light absorbed is measured and reading for concentration can be obtained. And the flame atomic absorption is, yeah, sorry?
Sorry, you are kind of just,
Pardon?
Nico, you kind of just paused for a bit.
Pardon,
Yeah, so if you could just repeat your sentence again.
Sorry. We are talking about the FFAS and the GFAS, and these are techniques that have until recently been the first choice of analytical chemists for trace element analysis. And let's have a closer look at the FAAS. This technique is based on the principle that ground state metals absorb light at a specific wavelength. This is how when the metal ions in a solution are converted to atomic state by means of a flame. And then when light of the correct wavelength is supplied, the amount of light absorbed is measured and a reading for concentration can be obtained. And the flame atomic absorption is a very accurate quantitative technique and also a good qualitative. However, the problem here is you cannot go to the very low detection limits. GFAAS, for example, is using electrothermal heating. A graphite tube provides a small contained area for atomization, and the high temperature capabilities and containment of the sample allows for complete atomization. The GFAAS is able to detect some elements down to ppb levels. Actually, the GFFAS offering detection limits which are about a factor of 20 to 200 lower than for FFAS, which is usually the standard method for many trace elements. It's especially for the background values and for unpolluted samples. Today, the previous mentioned techniques are frequently being replaced by the modern, more sophisticated instrumentation, such as ICP-MS and ICP-OES. Also, the technical advances are improving the sensitivity and detection limits of most analytical techniques, instrumental limitations, such as difficulties in performing multi-elemental simultaneous studies, still remain in advanced analytical technologies. That's the reason actually why in many applications ICP-MS is often considered as the ideal instrument to perform fast multi-trace element analysis. Because this technology allows a fast qualitative analysis of unknown samples and quantitative multi-elemental analysis down to PPT or even PPQ levels. The actual detection limit depends on the instrument, the matrix, the sample preparation, and of course the condition of the instrument. ICP-OES quantification is based on measurement of excited atoms and ions at the wavelength characteristics for the specific elements being measured. ICP-MS, however, measures an atom's mass by mass spectrometry. Due to the difference in metal element detection, the lower detection limit for ICP-MS can extend to parts per trillion, with a lower limit for ICP-OES, it's parts per billion. Obviously, if the elements for detection have regulatory limits that are below or near the lower detection limit of ICP-OES, ICP-MS is the instrument of choice. ICP-OES is mainly used for samples with high total dissolved solids, so with a high TDS, or suspended solids, and is therefore more robust for analyzing the groundwater, wastewater, soil, or for example, solid waste. But it can be also used for drinking water analysis as well. But in general, ICP-OES is used to measure contaminants for environmental safety assessments and elements with a higher regulatory limit. ICP-MS, on the other hand, is especially used for analyzing samples with low regulatory limits. In addition, ICP-OES has much higher tolerance for TDS, because for ICP-MS, on the other hand, you have a very low tolerance. It's just about 0.2%, whereas you have 30% for TDS, for ICP-OES. Although both ICP-OES and ICP-MS can be used for high matrix samples, sample dilution is often necessary for the use on ICP-MS. Let's compare the different analytical technologies. If you have a look at the FAAS or Flame AAS, it's inexpensive and fast, and it is suitable when only a few elements need to be measured. The problem here is it lacks a bit the sensitivity and range of the applicable elements to meet all the US and EU environmental legislation requirements. GFAS provides a lower detection limit to key elements, such for example as cadmium, but it is slow and more expensive. This technique is best applied when relatively just a few elements need to be measured in a small to medium number of samples. The newer technologies like ICP-OES, this is more sensitive than Flame AAS, and it is a multi-element technique. It performs a rapid analysis for environmental samples at the ppb to ppm detection levels, but it is sadly, of course, more expensive than the simple AA instrumentation. The ICP-OES is ideal for medium to high sample throughput, where ultra-low detection limits are not required. ICP-MS is very fast, it's sensitive, and it's a multi-element technique well suited for low-level elemental analysis. It is more expensive than ICP-OES, but it is essential for meeting the lowest concentration requirements for US and EU environmental legislation. All of this you can also see simplified in the slide. You see the measuring range of the different technologies and then the detection limit. And here you can see the speed in comparison with the low detection limit. So let's have a look at the water requirements. Where is the water used for? You use the pure water the ultra pure water for the preparation of standards, for blanks, for sample preparation, for your instrument cleaning, and for the washing and rinsing of sample and reagent containers. So water is not used during the analysis step actually. However, sample preparation step, blank and standard preparation require the high purity water. And the water selected actually must meet two basic features. You need to avoid interferences with the ions being analyzed, and you need to enable the instrument to run in optimum conditions. Because the water is utilized early in the overall analytical process, a contamination stemming from the water would carry on throughout the analysis and compromise the whole analytical process. This is why it's so important to have a good water quality. In ICP-MS or ICP-OES, trace element analysis ultra-pure water is used extensively. It is often present in the mixture of at high percentage compared to other mixture components because it is used for direct dilution during sample and standard preparation as a reagent blank and for instrument and sample containers. Any contamination, and in particular in this case trace element contamination introduced during sample preparation, will carry throughout analysis and affecting the final results. So therefore the water selected for the trace element analysis must be of a very high and consistent quality and should not contaminate samples or the analytical instrument with elements. Let's have a look at the impact of the water quality. So over the last decades, actually, the detection limits expected for some elements has been dramatically improved. That's also what I said at the beginning. So the limiting factor nowadays of the analysis is not really the reagent purity, including the water, but actually the analytical technologies. And while this observation remains true for some elements that are hardly naturally present in water nowadays, the sensitivity of the instruments is such that reagent quality might interfere with trace analysis for some elements. Once again, that's why it's so important to have very high purity of the water. Because blank levels of a given element are affected by such factor as the purity of sample treating solutions, container purity, and the general analytical environment. Among the various reagents used during the key steps of blank standards and sample preparation is ultra-pure water. The investigations are often performed on the background of tape while aspirating air, pure acid, or ultra-pure water. So the ultra-pure water, such as that is produced by our, NAPTEC, the ultra-pure water systems, they're causing less spectral interferences than, for example, high-quality nitric acid. Also, if you purify the acid by subboiling, the trace element concentration are still above those of ultra-pure water produced by our units. And keep in mind that 18.2 megohm is no longer a quality certification value because this shows you only the amount of ions. Because studies concerning that ultra-trace analysis show that blank optimization is only achievable when ultra-pure water with sub-ppt level contamination for most of the elements is used. Contamination risk in the pharmaceutical industry sorry. The contamination risks are greatly increased when the ultra-pure water is stored. And the results clearly indicate that the quality of high purity water degrades with storage time. In addition to clean air, the laboratory needs an ultra-pure water supply, and the analytical instrument, or at least the sample preparation station, should be located close to the water outlet. That means it's not a good idea to store ultra-pure water. So if you withdraw water directly from the ultra-pure water system, please use it directly without storing it in a container, without carrying it the whole time, because the problem is that the ultrapure water directly reacts with the atmosphere and try to get back the ions which you removed before. So the results expected are very much dependent on the analytical conditions and environment of the laboratory. So working in a clean room will allow reaching significantly lower detection limits. Let's have a look at the water impurities. Obviously, the water needs to be free of traces of elements. So any trace of ions in the water can interfere with the analysis. We talked before that actually the 18.2 megohm resistivity is a minimum requirement, but also other precautions should be taken to ensure that no ions ever leak from the water purification unit. And this may include the use of a safety ion exchange cartridge to prevent release of ions upon exhaustion of the cartridges. So that means is usually we are using a high efficiency ion exchanger as the final polishing step to reach the very low ion level. So to remove all of the ions. But of course, this ion exchanger has a finite capacity. And if you reach this finite capacity, all of the ions which we are holding back before, they will be released at once. So that's why it makes sense to have two polisher instead of one, to have kind of a polisher who will take care if the first polisher will release the ions. But it's also important to have other final filters with absorption capacities for metals. That's, for example, why we use a high efficiency absorber additionally to the high purity resin. And it also requires a careful selection of the tubing and valves to avoid any contamination of the high purity water. The particulates, for example, they must be removed to avoid a spoilage of the nebulizer. In addition, some metals also may stick to particulates and perturb the analysis. So an inline 0.05 ultrafilter and a 0.2 sterile filter at the outlet of the purification unit is used to prevent particulates release from the water purification unit. To reduce large quantities of organics, we use UV lamp because large quantities of organics would stick on the nebulizer walls and result in a more frequent cleaning. In addition, also some metals from organometallic complexes, so for example like platinum, mercury, tin, or palladium, that form bonds with organic content. In order to ensure these low levels of those elements in the water, it is important to break down the organometallic complexes and remove the metals. So that's why we use the photooxidation. That means a UV lamp. The metals then liberated in the water, they can be removed with the following ion exchanger. And the high performance adsorber reduces organics as well and is utilized to decrease the overall organic content. Last but not least, the bacteria. It is also important to maintain the bacterial count as low as possible in the water because bacteria can release ions and they also behave as particulates. So therefore, they can also interfere with the ions dosed and spoil to the nebulizer. So various means are utilized in the purification unit to control and reduce the bacterial level. So also here, the UV lamp is used with actually a dual wavelength UV lamp with 185 and 254 nanometer with the combination of the sterile filter at the point of use to remove as many bacteria as possible. Let's have a look at the different kind of technologies which we are using to purify the water. So now we will skip to the production and to the storage of the required ultra-pure water. So first have a look at the reverse osmosis. The reverse osmosis is still the most economical method of removing up to 99% of all of the contaminants. The production of high quality ultra pure water usually requires a combination of technologies. So the first purification step is usually the reverse osmosis, due to the fact that's the most economical method. So what we are doing here is you have a membrane and then you have a pressure pump and you try to push the water through a thin membrane to remove up to 99%. As well with the membrane of the ions, as well you reject 90 to 95% of bacteria, pyrogens, and other inorganic solids. Now have a look at the EDI technology. The EDI technology is a key step in the production actually of ion-free water. Because the EDI module, where a direct current voltage is applied to the resin containing cells, maintains a consistent water quality with no fluctuations due to the changes in the feed water ion concentration. Unlike to the normal ion exchanger here, the EDI cell doesn't have a finite capacity because in contrast to the normal ion exchange, it regenerated automatically via the electric current. And the high resistivity water produced presents then a low ionic challenge to the ultra pure water polishing resin. Because the problem of the EDI cell, yes, we remove a lot of ions, but there is still a small amount of ion left. That's why you have the combination of an EDI cell and after this an ion exchanger. So the purified water from the EDI cell is then processed to a polisher, where then the additional technologies produce the ultra pure water, which is then suited for the ultra trace analysis. And the best ultra pure water to optimize blanks and prepare standards is obtained by adding the UV photooxidation technology as well. So in our case, we use a dual wavelength UV lamp upstream of the polishing pack to ensure the destruction of the organics, including those with the trapped metals. And the released elements then can be retained by the following polishing cartridge. So why do we have two different kind of wavelengths? Because 254 nanometers has the greatest bactericidal action as it prevents the replication of the organics because it destroys the DNA. Whereas actually the 185 nanometers is the most effective wavelengths for oxidizing the organics. So that means with the 185 nanometers, we can really lower the TOC value. We oxidize the organics, and then after that, we can remove the rest with the ion exchanger. Last but not least, we are talking about the polishing module. This is also, let's say, a simple demineralization. And the ultra pure water system uses the high quality ion exchange mixed bed resin in a pure neutral PP housing. So it's also important that, of course, you only use the best possible material, not only the purification technologies. So of course, you always have to keep in mind that also the material inside the water purification system are actually suited and not releasing some ions once again to the water you purified before. And additionally, after each polishing module, we have an accurate resistivity sensor, which is placed downstream of every cartridge in order to monitor even the first ionic release from the cartridges. Then the final filtration is then ensured through the 0.2 micron filter at the outlet of the system. Additionally, an optional ultrafilter with a pore size of 0.05 micron is also highly recommended to ensure the best possible water quality and to remove, for example, colloidal traces. Of course, after purifying the water, it is also necessary to store the water somewhere. So the purified water is usually stored in an intermediate reservoir to provide an adequate flow rate to feed ultrapure water systems. Because the problem is that usually the reverse osmosis has a lower production rate. And if you always need to wait for the system to produce water, if you start you need it, it could be a bit annoying. That's usually why you store the water in a storage tank. And of course, what we did is we had numerous tests to select the right materials and the construction of the tank reservoir. So because we want to limit the water degradation, because honestly, if you start storing the water, there's always a decrease of quality. You cannot avoid that. But of course, we want to limit the water degradation during the storage as much as possible. And as a result of these tests, we chose materials like polyethylene with a low extractable level. Additionally, all of our tanks have a stable overflow and a stable vent filter with a CO2 absorber. Keep in mind that the storage tank should not be larger than a 1 day's consumption, because of course a big storage tank also can lead to a contamination if you don't use the water regularly. What can also be helpful is a UV disinfection inside the tank, because also this always prevents from an organic growth on the, in particular on the walls of the tank. Let's have a closer look actually on the systems we provide for trace elemental analysis. So actually you have different models to choose for. So we will focus here on our Helios and on our Helios 612 series, because these are the systems which are usually most common, as you don't need that much water. And these kind of systems give you the best possible water quality. So let's have a look at the Helios system. So all of our systems have a complete quality recirculation. That means that the water inside the system circulates from time to time through all of the filters which are placed inside the unit. So no stagnation of the water and no growth of some organic or other content can be in the system, as well as you always have the best possible water quality at the point of dispense. Of course, the circulation is really until the tip of the external dispenser. The nice thing is with the Helios system is that you can place the production unit wherever you want. So for example, under the bench, and you just put the external dispenser on the bench. The systems have the option of real-time TOC monitoring. It is possible that after each withdrawal, the system creates a withdrawal report and store this withdrawal report internally. And this one can then be exported via a USB outlet. so that you're always sure that the water is used for your analysis can be traced back. Our Helios, we have an integrated pre-filter and an integrated ultra filter. Integrated pre-filter means this is the first polishing cartridge. As I said before, we measure after each polishing cartridge. So after, even if there's a small leakage of ions after the first cartridge, you can already monitor and can change it so that you are sure that at the point of dispense, there's always the best possible water quality. Additionally, we have an integrated ultrafilter. This is the 0.05 micron filter, which is located inside of the unit. The big advantage here is that this filter is flushed regularly. So that means the lifetime of the integrated ultrafilter is up to 3 years. Instead, for some competitors, they have to change them every 3 months. Of course, all of the material which we are used in our system is selected carefully. So what we have is a superior deionization and the TOC removal. How can we achieve that? Of course, we achieve that we only use materials which are suited for ultrapure water, as well as we use a specific high quality absorbance resin additionally to the high purity resin. All of the systems come with an integrated leak water detector in case there is a malfunction of the unit and an integrated pressure reducer. So the systems are ready to connect. But keep in mind the Helios needs pre-treated water. So when we have a look at the simplified flow diagram, we need pre-treated water. Pre-treated water means we have already an existing reverse osmosis, or we have an ion exchanger, or we have a central water purification system, for example, with RO and EDI. Then we can enter the system. We have a small screen filter in front. Then we have our, excuse me. Then we have our pressure reducer. So that means you don't have to worry about the inlet pressure. We have the inlet solenoid valve and we have a flow meter so that you have a very accurate volume dispensing. The pressure pump, we have a built-in pressure sensor, the built-in pressure sensor measuring the operating pressure, as well as this is your dry run protection for the system. So I think I left with talking about our pre-treatment. So we have the integrated pre-treatment, which is inside the unit. And inside of the pre-treatment, there's already a high purity resin, as well as the high performance absorber to lower the ion level almost to 0, as well as to lower the organic content. After the cartridge, you already have a measurement. That with this measurement, you can detect if the cartridge will exhaust soon, and then you can replace it as soon as possible. After that, you have the UV lamp. As I told you, we use a dual wavelength UV lamp with 185 to 254 nanometers to disinfect and, of course, to reduce the TOC. Optionally, you have an additional measuring cell for the TOC monitor. And then you have the final polishing module. This lowers the ions to 0. So after this, you have 18.2 megohm and the lowest possible TOC as well. Then, optionally, you have the recommended ultrafilter. As I told you before, the ultrafilter in our system is integrated. That means this is flushed and the ultrafilter has a lifetime of up to 3 years. And then before the dispensing point, you have the final measuring cell. and then you can go to the external dispenser. Actually, up to 4 dispensers can be connected to one production unit. But what to do if you don't have pre-treated water already? So if you just want to connect to tap water, then the Helios 6 or 12 could be the right choice. Here as well, you have all of the features which you already had with our Helios system, but additionally, you have below a 10-liter tank. If the 10-liter tank is not big enough for the storage of the water, of course, 30, 60, and 100-liter tanks are also available. Just keep in mind, the tank shouldn't be too big, just 1 day consumption. But all of the nice features you also have with the Helios, you have with the Helios 612 as well. So you have, of course, the quality circulation, in this case, from the tank through all of the filters to the tip of the dispensers and back. You have the optional TOC monitoring, you have the data capture. In this case, you also have an integrated pre and ultra filter. You have actually 2 leak water detectors, one inside the system and one inside the tank. This system actually is also available with an EDI module to even have a better water quality. And in particular, when we talk about trace elemental analysis, it is important to have the best possible water quality. So when we check here the simplified flow diagram, we can see we can connect it directly to tap water. We have a small screen filter. We have then also here, in this case, a pressure reducer. So you also, once again, you don't have to worry about the feed water pressure. What's important that there is some kind of feed water pressure. So minimum 1 bar is recommended. Then we have our solenoid valve. We have the pressure pump. And this is here, in this case, the pretreatment. Unlike the Helios, the pretreatment here is really in front of the reverse osmosis membrane, just to protect the reverse osmosis membrane. Because the RO doesn't like chlorine, it doesn't like particles, and it doesn't like hardness. This is why it is important to put a pretreatment before the RO. This is inside here, so we use a special filter material as well as something similar to activated carbon to remove all of the elements which can harm the reverse osmosis. So then you have the reverse osmosis membrane. With this, as mentioned before, you can remove up to 99% of the ions already. Then this is the optional EDI cell. This one is also highly recommended if you do the trace elemental analysis. It's not mandatory, but recommended. And with this, you bring down the conductivity to lower than 0.1 microsiemens already. So that means already higher than 10 megohm. So that the polishing module, which is here, only has to remove just this little bit of ions which are still left. After the EDI cell, you have here a flow sensor. With this flow sensor, you measure the production rate, as well as this is also necessary for the volume dispensing. Then you have here a measuring cell for measuring the permeate or the EDI. The UV lamp, optionally the TOC sensor. Then you have the polishing module for the final polishing for the best possible water quality, and the ultra filter, which is also highly recommended. And then short before the dispensing points, you have the measuring cell, and then you go to the tank. All of our tanks, of course, they have a sterile overflow and a sterile vent filter, so that we really maintain the best possible water quality also inside the storage tank. Then the storage tank is cyclically circulated through all of the filters once again, through all of the dispensers and back to the tank. So this also is necessary to maintain the best possible water quality inside the unit. Here you can see some of the key features of our systems. All of our systems have an innovative user interface. That means you have a 5-inch touch screen where you can monitor all of the important values like conductivity, resistivity, TOC, temperature, flow rates, pressure. And of course, it's a smart monitoring. That means it always tells you if something is wrong. You have a clear text. So it explains if some spec is out of the specifications. Our systems are always plug and dispense. That means you just connect the systems to the tap water and of course connect the electricity. That's it. Then the system is directly running. The normal Helios have the external tabletop dispenser, the ergonomic design to optimize your lab space. Of course, you have the maximum flexibility because you can detach and reattach the dispenser handle, and you have a high precise volume dispensing. Of course, we have also systems with an integrated or an attached dispenser to the system, as well as systems with fixed dispenser. But of course, you can get in contact with DKSH if you need some more information. If we talk about the production unit, here in this case, the production unit is separately. So that means you're flexible. You can place it wherever there's space in the laboratory. The main focus here is on the quality of the parts so that you have a reliable operation, because of course the worst thing which can happen is that you don't have ultrapure water anymore. Due to our big filters, we have low operating costs. And of course, validation documents are available for all of our units. This is how our software looks like for the Helios systems. As I said, we have some unique features. We have a simple and intuitive user interface. It's similar what you already know from your mobile phone or from your smartphone. We have this internal storage and the data output, which then ensures the history of all of the withdrawals and of course of the alarms, and different languages are available. Here, for example, this is how the dispensing screen looks like. So you can set actually the volume freely. So you have the dispensing wheel on the dispenser handle. With this, you can set that the volume in 50 milliliter steps. If this is not accurate enough, you can use the touchscreen to choose any volume you like. This here, for example, these are some warnings and some error messages. As you can see here, it's clearly written, and usually it's also mentioned what you need to do to get rid of the error message. These are actually more or less a lot of benefits at a glance, so that you can see what makes our system different to our competitors. As I told you, we have the plug and use. That means you will just connect all of the consumables, you connect all of the tubes, and then you have an automatic initialization. Just follow the steps which are mentioned in the manual. It's very easy. You have the integrated pre-treatment module, so that means no external pre-treatment is necessary anymore. So that you can just connect it directly to your tap water. You have the internal circulation, including also the tank, so that you really are sure that nothing can grow. You have the leakage detectors. In the Helios system, one leakage detector in the Helios 612. So that means if you have a system with RO and tank, you have even two leakage detectors, one inside the production unit and one inside the tank. So in case of a leakage, the system will recognize it and will close the inlet solenoid valve. So there cannot be, we cannot flood your laboratory. The precise and variable volume dispensing, we have the integrated ultrafilter. We monitor different sensors, for example, also the pressure and the production rate. We have this dry run protection, and of course also the system, they are 100% made in Germany. so that we can really keep up the quality, because this is our main focus. So what we are offering is, of course, this is just the glimpse of our product line. These are the products for the trace elemental analysis. Of course, we have a much larger portfolio. We have ion exchanges as well. We have bigger systems as well. So we offer a wealth of innovative products and technologies for actually a wide range of applications. And as I mentioned before, all of the systems are made in Germany, 100%. Built and tested, and of course also sent from Germany. And we gave to all of the systems 2 years warranty. If you're interested, just contact the DKSH or go to our feel free to go to our website to www.neptec.de to find out more about our products. And of course, if you have any questions, just let us know. Yeah, thank you very much for your time, and I'm once again sorry that I was disconnected for a few minutes. I hope that won't be such, or that hasn't been such a big issue. And yeah, giving back to Bernadette.
All right, thank you, Nicole, for your time. And audience, once again, so sorry for the technical issue earlier. And we hope that you have taken down some important notes from Nicole's presentation. And with that, while the content is still fresh in our heads, maybe we shall start with our Kahoot quiz. So allow me to just share my screen so that you can see the game pin. Nicole, could you let me know if you can see my screen?
Yes.
All right, audiences. So to participate in the Kahoot quiz, you would need to access Kahoot via your mobile phone. So what happens is that with your mobile phone, just open your internet browser and key in the game pin that you see on the screen right now, 5086708, and you select enter, and then you will be prompted your nickname. Simply key in your nickname and select enter. We will just wait for a couple more people to join us. And so how the game would go is that we have about 8 questions. And once the question is flashed on the screen, you will have a timer of 20 seconds. And you would have to, select the correct answer via your mobile phone. So your mobile phone acts as a control. And as I said earlier, the points would be given based on your accuracy and your speed. All right, without further ado, let's just begin. So the first question, the importance. All right, if you just look at your WebEx screen and using your mobile phone as the control, the first question goes, which country is Neptec lab water system manufactured in? Singapore, USA, Germany, or India? All right, we have most people getting it correct. Congratulations, GN. You're first as of now. So the next question, ASTM type 1 water is also known as DI water, R water, pure water, ultra pure. You have about 10 seconds left. All right. The answer is ultra pure water. Let's see. Oh, congratulations, Ginny. Next question. Which STM water types can NABTEC Helios 6 produce? So this is a bit tricky because it's a combination answer. We have about 10 seconds left, and let's see if Ginny will still be ranked first. Correct, the answer is type 1 and type 2. Let's look at the ranks again. Oh, congratulations, Ong and Marcus. You guys are going up the ranks. And the next question, what is one of the functions of UV lamp in the water system? Is it to reduce TOC content, reduce inorganic particles, remove your ions, or it's just for decorative purposes? Congratulations. The correct answer is reduce TOC content. Let's look at the scoreboard. Oh, let's see, Ong, if you can beat Ginny for the next 4 questions. How many years of warranty is offered for NABTEC lab water systems? Nico mentioned it towards the end of his presentation. Let's see if all of you can get it correct. The answer is 2 years. All right, moving on. All right, next question. You have 3 more questions left. Which analytical technology is very well suited for low-level elemental analysis? ICP-MS, ICP-OES, visual test, or none of the above? Right, the answer is ICP-MS. Majority got it correct. Oh no, Ginny. All right, moving on. What is ultra pure water not used for in ICP-MS and ICP-OES? All right, this is pretty straightforward. So let's move on to look at the scoreboard. June, Marcus, and Eileen, you're coming up the ranks pretty high. The last question, why is flame atomic absorption spectrometry still one of the most widely used methods for trace elemental analysis? This is pretty tricky. Nico covered it at the start of his presentation. We have 5 seconds left. Answer is that it is relatively cheap. All right, let's look at our final scoreboard and see who's the first one. Congratulations, Marcus, you're ranked 3rd. Ginny 2nd, and the first one, the winner, JN. Congratulations, JN. You will bring home a set of Apple AirPods today. So I will drop you an email on how to claim the prize. So do look forward to my email. And with that, let me just stop sharing my screen so that we can move on to the Q&A segment. All right. If we refer back to our WebEx screen, we have a couple of questions. Nico, are you still with us on the line?
Yes, I am.
Yes, Nicole, we actually have a couple of questions. We have about 4 questions currently in line. And once again, audience, just a quick reminder, if you still have questions for Nicole, do pop them in the Q&A box on your right panel. So Nicole, the first question goes, what's the pore size of the ultrafilter?
The ultrafilter has a pore size of 0.05 micron. So 0.05 micron.
0.05 microns, all right. The next question goes, does UV lamp or TOC values impact on trace elemental analysis, especially for inorganic samples?
Pardon, can you repeat? I didn't understand correctly.
All right, I will just pop the question into the chat for you to see, Nicole. So if you refer to my message, the question goes, does UV lamp or TOC values impact trace elemental analysis, especially for inorganic samples?
Yeah, what the UV lamp does, it's lower the TOC value and of course also reduce the organic content. So if you have elemental analyzers for inorganic samples, UV lamp is not necessary.
All right, thank you, Nicole. One more question that we have. Without the sterile 0.22 micrometer filter at point of use, will it affect the results from ICP?
Sorry, pardon. Can you repeat once again?
Yep, I will just pop the question in to the chat box for you. So again, let me just repeat the question for our audience. Without the sterile 0.22 micrometer filter at point of use, will it affect the results from ICP?
If you have an integrated ultrafilter, it shouldn't be an issue because then you have an inline 0.05 micron filter. If you have that, not an issue. If you don't have, we would highly recommend to use the sterile filter because of course it removes also particles which could be still inside the water.
All right, thank you, Nicole. We still have two more questions. So I've popped one of the questions in for you to refer to. Do you recommend to have EDI in a lab water system? And how does it affect or will it help to improve the lab water quality?
At first, no, because what we are doing here is if you don't have the EDI and you have the reverse osmosis, for example, with a simple polisher, at the beginning it's fine, but the problem is the polisher has a finite capacity. So when the polisher starts being go to exhaustion, then it releases the ions. If you have an EDI on the other hand, then this removes already a lot of the ions and it will regenerate automatically. So there is a lower risk of the releasing of ions when the polishing module goes into exhaustion. So finally, will it increase the quality at the beginning? No. Long term, yes.
All right, thank you, Nicole. We have one last question. Does the temperature of the UPW DI water affects ICP OES readings?
Oh, actually, yes. I'm so sorry, but I cannot answer this question. I'm not a cat. I'm very sorry, but maybe is there someone in the audience who could answer, but this is not my field of expertise. So I'm very sorry. There, with this question, I cannot help.
All right, maybe for this question, we would get our colleagues to reach out to you privately. So with that, that concludes our webinar for today. Thank you, Nicole, and everyone for attending today's webinar. And if you have other questions, feel free to contact me at bernadette.lim@dksh.com. And you will also receive a follow-up email within 2 to 3 days with a link to view a recording of today's webinar. So on behalf of DKSH and Nicole, thank you for joining us today and have a great day ahead. Thank you so much, Nicole.
Thank you very much. Have a great day, all of you. Thank you.
Thank you.